I apologize, the video got caught up. This is the next example for 10.12. It says graph, describe the midline, describe the amplitude and the period. And in here we have f of x equals 3 cosine of x minus pi over 2 plus 2. This is a change in amplitude. The second one is a change in a horizontal compression or stretch. It just means instead of 2 pi, how long does it take for the cycle to take place. This is related to the horizontal shift, and this is a vertical shift. Okay, so personally I prefer to start with the horizontal compressions or stretches. Second, I go with the vertical or the change in the amplitude, which is vertical stretch or compression. And at the end, I just do the two shifts together. In here, we don't have a horizontal stretch or compression, so we'll go to the amplitude first. For some people, it's easier to do individually each of the transformations one at a time. I'm going to do it both ways. For some people, it's better to do the stretch and after that do the shifts. So we're going to do the two different ways so that you can have and choose whichever you prefer. So we're going to start with the mother graph. Cosine, it's going to start 1, 0, negative 1, 0, positive 1. And remember that it's curved, so that's our mother graph. It takes one period because remember that it's repeated. This goes on and on in both directions infinitely. And so for one period means that after that it repeats again. You start over here and then go down and up, go down, and so it's a repetition. So in pink, I'm going to do the different ones and dot it for the different steps. Or the different transformations, but then I'll do the final one in blue, and that's the one that counts. Okay, so in here, since we don't have a horizontal compression or stretch, we're going to go to the A, which is an amplitude. Okay, and what does the amplitude do? It multiplies by 3. So in here, the 3 tells me that the amplitude is not 1 anymore, meaning from the point to the midline, it's only 1, right? And it's the absolute value. So but you have to multiply it by 3. So instead of 1 being the amplitude, the new amplitude for that point is going to be 3. But we start counting from here because some people want to count 3 from here. So no, it's 1, 2, 3. So it's right here for the new point of that point. And you can start in any point. In here, 0 times 3 is just 0, so it's going to stay right there. For this one, the amplitude is from that point to the midline. And I guess I could have drawn the midline from the beginning. This is the midline. Okay, and so 1 times 3 is 3. So I start counting from here. 1, 2, 3. That's my new point right there. Again, for this one is 0 times 3 is 0. Right, 0 times 3 is 0, so it stays there. The amplitude here is 1. 1 times 3 is 3. So now we count 1, 2, 3. But that's only the amplitude. Okay, it changed the amplitude only. And we still need to work with the other parts, so that's why I'm writing it dotted. It's not the actual final transformation. Okay, so that's just for this part, but we still need to do the horizontal shift and the vertical shift. How do we find the horizontal shift? Also called the phase shift. So to do that, we're going to equal whatever is inside of the parentheses. And some people just say, oh, just get the opposite of this because it's negative c. Remember from our beginning in the first part of this video, we see negative c. That means you change the sign. Or you can just equal the whole thing inside of the parentheses to 0. So x minus pi over 2 is equals to 0. I add pi over 2 to both sides. this cancels, and so x is equals to pi over 2. That means that the graph is going to be moving that much space, and it's in radians. Remember that in radians for x, pi over 2 is just 2 squares. That's how we're representing it here. So this is going to move up 2 spaces, and this is going to be moving to the right pi over 2 spaces. Okay, that's what that means. So it's easier to just both at the same time. Pi is going 1 right here, right? That's pi over 2 for this point. Pi over 2 is right here, and then 2 spaces up. 2 spaces means from 3 to 4, and from 4 to 5. That's 1 space, 2 spaces. So my new point for that one is right there. For this point, you have pi over 2 plus pi over 2 is a whole pi, and 2 spaces up, because of the vertical shift, your new point is right here. This one goes right here. This one, again, pi over 2 is this many spaces, and then 1, 2. Here is your new, this point, pi over 2 to the right, and then 1, 2. It's right there. Finally, this point, pi over 2 to the right, 1, 2 up. So that's, since it's all my points already shifted, I already did the amplitude. I'm changing the horizontal shift or the phase shift, and also the vertical shift. Then I'm done. I can connect it with the blue because that's my final. Okay. And for me, it's easier to just grab from the bottom, kind of, and then to the other point. Remember that it's a curve. From here. So that has all 3 transformations. The only thing that this doesn't have is a horizontal stretch or compression, which would be a number here. How would you go from the mother graph directly to here? Is that if you don't do this, you don't put the point in there, you can just do all 3 steps at the same time. And so what you do is that if this is 1, you do the amplitude is 3. Okay, 1, 1, 2, 3. That's my new amplitude. But then to that new point, you move it. You do have to do this part. You move it pi over 2 to the right. So pi over 2 to the right is right here, and 2 spaces up, 1, 2, and you just put it there. For some people, it's easy to just do that. In here, 3 times 0 is 0. The shift to the right is pi over 2, and then 2 movements up, 1, 2. That's my new point. For this one, it's -1 times 3 is -3, so 1, 2, 3. But then pi over 2 to the right, and 2 spaces up, and that's my new point. For this one, 3 times 0 is 0. Move it pi over 2 to the right, move it 2 spaces up. That's my new point. For this one, it's 1 times 3 is 3. So 1, 2, 3. Pi over 2 to the right. 1, 2, up. And that's my new point. And then connect them. Some people can do that. If you are able to do that, great. You can do it if you want. Either way, we'll end up in the same place. And so for when it says that describe the midline is now at, and some people guide themselves with this, but for me it's easier to just count from each point. And basically there is no wrong way to do it. Some people prefer to first move that midline with the original cosine going like this. Okay, and then from there doing the amplitude and also the horizontal shift. So you can do it whichever way you want. You will end up with the same graph. What is the midline? The midline now, it's at 2. Okay, the amplitude is 3, meaning that it's not one space away from the new midline, but 3 spaces, 1, 2, 3. Okay, so the amplitude, and I'm writing it incorrectly, is 3, and the period is stayed the same. It's still 2 pi. Okay, period did not change, is 2 pi. Okay, from here, pi over 2 to 5 pi over 2, it's 1, 2, 3, 4, 4 halves. 4 divided by 2 is 2 pi. Okay, here's another example. It says graph, describe the midline, amplitude, and period. And so the mother graph is sine. Remember that sine start at 0, 0. Then 1 when it's pi over 2, 0, -1, and 2 pi. Okay, so that's my mother graph. And so what we're going to do, again, we're going to be doing different transformations. For some people it's easier to just go directly, and I'm going to do a couple of steps with this one, but then the final graph with all 3 transformations, this one has 3 transformations as well, will be in blue. Okay, so as I said in the previous example, I prefer to do the horizontal compression or stretch first, then the amplitude, and finally the shifts. In here we only have vertical shifts. We don't have a horizontal shift, which is adding or subtracting something. That's when you have a horizontal shift. And so to find the new period, remember that sine has a period of 2 pi, meaning that a whole cycle is 2 pi. But then in here, to find the new cycle, what we're going to do is that we're going to use our formula of 2 pi divided by b. And b is this part right here, the coefficient of x, whatever is left of x. This is my b. So I'm going to divide 2 pi by 2 pi. In this case, 2 pi happens to be b. 2 pi divided by 2 pi cancels, and so your new period will be 1. If you saw the previous video, which is 2.11, if you recall, this doesn't have pi. This is in radians. So this is just 1. Pi, meaning from here to here, is 3.14. So I just take a little piece away, and then the rest I divide into 3 because it's 3.14. So I said that 1 is about there, 2 is about there, and then 3 is right there. So 1, 2, 3. What does that mean? It means that this original or mother graph has to fit now into only one right here. Whew. This is half of the graph. Going down is the other half of the graph. What does that mean? That 1 is right here, so half of that will be around here. What that means is that I have to go up to 1. This is 1 right here. In just up and down to this middle of 1. Okay, so up and down. Look at that. And then for this part, we'll go in the other half. So more or less about there, you have to go down to that point. So my new compressed graph, and this is the part that I said I cannot find that point and then move it up and down and then the amplitude. No, I need to do that part first and then be able to move it. Okay, so that's just that compression right there, the period. Okay, now I'm going to do the amplitude. It says multiply by 2. So that is now multiplied by 2. This point is going to be here, and then I just move it 3 spaces down. So 1, 2, 3, right there. This point is now here. This times 2 is 0, because it's at 0. 0 times 2 is 0. And then I just move it 3 spaces down. So 1, 2, 3. This one is -1 times 2 is -2. and then move it 3 spaces down, so it's 1, 2, 3 right there. And then this is 0 times 2 is 0, minus 3 is 1, 2, 3 right there. And so now I have all my points, right? Oh, and this one I forgot to move the middle one. It's 0 times 2 is 2 minus 3, so it's 1, 2, 3. It's right here, which is makes sense because you have 1, 2, 3 in here, but then on the middle of this is you have 1 up, and then in the middle of the last 2 you have 1 down. And so now your new graph goes something like this. Again, this is your final product, so that can go in blue. Okay, that's very stretched and very horizontally compressed, but that's your new graph. Look at that. Can you create something beautiful? Of course you can. So that's your final product. It has been compressed, horizontally compressed. That's your pink right there. The amplitude is now from this midpoint to here is 2, and then brought down 3 spaces. So the midline basically went down 1, 2, 3 spaces right there. Okay. So again, this is just one way to do it. I'll do it by shifting this first. Since we already have the period, then we'll do that. And then finally the amplitude. Okay, let's do it the other way around. Again, let's graph sine first. Okay, something like that. The midline is right here. That way you can see which one you prefer. And so the first thing that we're going to do is to go down vertical shift, so that we're going to go down 3 spaces. So it's 1, 2, 3. For the midline is going down 3 spaces. Okay, and that means that the new graph would be something like this. Okay, it's just we did the vertical shift only. After that, what you can do is the period, which is 1. We already said that the period is equals to 1 because you divide 2 pi by b, which is the 2 pi here. Okay, so the period we already found for it to be 1. So this is pi over 2. Remember that 1 is going to be around here, and that makes this 2 pi fit in there. Okay, so this will be half of the new graph, so it's going to go up and down to half of that, half of 1, and then here. And finally we multiply by 2. This amplitude right here is 1. By multiplying by 2 is twice as that, so twice as much is right there. And since we will be done, this is the last transformation. We can just do it like this, and then the same, the amplitude in here is 1 times 2 is 2, so instead of being 1 it's going to be 2, so it goes all the way here. And so that's how you would connect it. Again, it's up to you which of the two methods you want to do. Which do you prefer to shift it first, the midline, shift that first and then work with the rest, or do you prefer to do first doing the compression and the amplitude and finally the shifting? Do it as you find it easier, but at the end you will end up with the same. Okay, now we can say that the midline, it's -3 because it went down 3 spaces. The period is equals to 1 because before it was 2 pi, but now it's only 1 space, right? And for the amplitude, that's just twice as much. Okay, so you're multiplying by 2. So those are the descriptions for this graph. And now you're able to do 10.12, but if you can please give us a thumbs up. If you want more videos related to this unit, you can find the playlist around here. You can subscribe here, and the next video will be around this area. See you in the next video, and have fun!